Alright, next section in pre-calc is going to be 1.3. It's going to talk about functions and their graphs. We're going to break piecewise functions down, identify some of their characteristics, in particular how to evaluate them. And then we're going to talk about increasing, decreasing, constant functions, and max and min, and really intervals on where all of that stuff exists. And then finally we're going to talk about the algebra of how to identify even and odd functions. So first piece, a piecewise function is just going to be a function is defined by multiple equations, 2 or more, and they're all going to have their own specific domain. To evaluate, you're just going to choose the appropriate equation based on whatever the value of x is that you're given, and then you're going to do it just like we have in the past. You're going to plug in the value of x and simplify. So for our example here, you see that this piecewise function has 2 equations. We've got a 3x plus 5 is one piece, and 4x plus 7 is the other piece. So when we talk about negative 2 here, you see we're going to use that is part of this domain. It's less than 0. So we're going to use that first piece. 3 times negative 2 plus 5, and that would give us negative 1. When we talk about 0, that is in this other domain, which means we need to use the other piece of the equation, and that would give us 7. And then finally the last one, 3, is again greater than 0. So we're going to say 4 times 3 plus 7, and that'll give us 19. And moving on from there, then if we talk about increasing, decreasing, and constant functions, if you think about graphs of lines that you've done a lot in the past, it's the same idea as slope here. The slope is either increasing, meaning it's rising from left to right. The slope could be decreasing, meaning it's falling from left to right. Or finally the slope could be constant, meaning it's just maintaining a horizontal line from left to right. And on a graph, when we talk about that, one important thing that you probably want to add here actually is that when we talk about this, we're really only referring to the x values. So you're going to be coming up with intervals, like you see here. We have a graph. We're going to have intervals that we define as increasing, decreasing, or constant. And so all these intervals, we're only going to use our x values to define the intervals. So increasing, if you think about, again, your slope here, we're increasing from right here up until we hit this point. So this is increasing. And since we're talking about only x values, we want to say our x values increase starting at 0, and they stop increasing when we get here, and our x value there is 2. So our increasing x values are 0 to 2. If we look at decreasing, this first section right here is decreasing, so we're decreasing. And again, we need to make sure that we're talking about x values. This is where we tend to make a mistake. We see this arrow pointing up, so we want to say positive infinity. But in reality, since we're talking about x values, this arrow we need to think about more as going to the left, which means we start decreasing at negative infinity, and we're decreasing all the way until we hit this point where we turn, and that's going to be at 0. And there's actually 2 sections where we're decreasing, because again we're decreasing from this peak, and we're going decreasing down, down, down here, and we keep going down, which means negative infinity. Again, though, switching back, we want to think about we want to think about x, because we're going to the right. So we're decreasing starting right here at 2 for the x value, and we're going to continue going down, decreasing, but remember that means x value, so really we want to think about that as going to the right, which means we're decreasing from 2 to infinity here. And in this graph, there actually is no pieces that are constant. You see it's always decreasing, increasing, or decreasing. There's no horizontal lines, so we would just say none, or you could say NA, does not exist. Any of those are fine. Okay, relative maximum then, or maxima, either word is fine, is when we have a point that is the highest point relative to all of the points around it. So like a peak, and then a minimum is going to be a low point relative to all points around it, and that's like a valley. If we look at that same graph that we were just talking about, we're going to have a maximum at the high point here, and so we would just say that is at 2, 4, and our minimum is at this low point right here, which is at 0, 0. Okay, you could have several minimum, you could have several maximum, you could have none of either. In this case, we have one of each. And then finally, the even and odd functions. So we say a function is even if, when we plug in a negative value for x, we get out the same thing as the positive value. So when we plug in negative x, we get out the original function again. And it's going to have a specific type of symmetry called y-axis symmetry, which means if you think about having your graph, if we fold it in half across the y-axis, they'd be identical to it. An odd function then is when we plug in that negative value for x, we get a negative f of x, which means it's odd if all signs change. Okay, so it's odd if all signs change, meaning everything with an x and everything without an x, all signs change, that's odd. An even function, you can think about this, is nothing changes. So you plug in that negative sign, and in fact, they just kind of disappear, and we still have the exact same function we started with. An odd function is going to have symmetry with respect to the origin, which means it's kind of spun around the origin. It's almost like going over the y and the x. Looking at all of these then, it's to find if it's even, odd, or neither. We're going to say if I take my f of negative x, I'm going to have negative x cubed minus 6 times negative x. And what happens here, any negative number cubed stays negative, so we could say this is the same thing as negative x cubed, and a negative times a positive becomes a positive x, which equals the same thing as a negative f of x. So since all signs changed here, you see we went from a positive x cubed to a negative x cubed, from a negative 6x to a positive 6x, all signs changed. That tells us it's going to be odd. On the second one here, if I change colors, so I'm going to look at g of negative x. It's going to be a negative x to the fourth minus 2x, oops, that's a negative x squared. Well, any negative number to an even power is just going to give us a positive x to the fourth. And again, any negative number to an even power doesn't change anything. So you see this is actually the exact same function that we started with, which means this would be an even function. And finally, the last one here, if we plug in negative x, we'd have a negative x squared plus 2 times the negative x plus 1. So negative x squared, like we said, even index means that we can just drop the negative sign, or even exponent, so we drop the negative sign. This one would end up a negative 2x, and then we just have plus 1. So here it's not identical, but we don't have so nothing's the same. Not everything is the same, so it can't be even. Not everything is opposite, so it can't be odd. This one we would say is neither. Okay, one trick that actually makes this much easier than plugging everything in, and this is technically what we're doing, is plugging everything in, but you'll notice for an odd function, it had all odd exponents. So odd functions have nothing but odd exponents. Even functions will have nothing but even exponents. They could also have constants. So if I had like a plus 7 here, that wouldn't have changed anything. It would still be even. And then neither is going to have a mixture of both. Okay, so odd functions, only odd exponents. Even functions, even exponents, or they could have constants. And neither when you have a mixture of the two. Okay, so that's it for today's lessons. Next time in class, we're going to be looking at graphs of piecewise functions, kind of continuing on with what we looked at in 1.1 and 1.2, where we find where they're increasing, decreasing, their domains, their ranges, their max, their mins, that kind of thing. And then we'll move on and do some algebra of even functions, meaning plugging in those negative x's and seeing what we get.